Good morning, dear students. Today I am going to teach you a new topic, that is concept of axis, from chapter 5, that is motions of the earth. We have studied a lot about a beautiful planet, the earth. Okay, we are going to discover a bit more in today's lesson. We already know that the earth actually undergoes two important movements of the earth, and that is rotation of the earth and revolution of the earth. But now I am going to discuss about the topic, that is concept of axis. Students, axis refers to the imaginary line on which a planet rotates. Earth's rotational axis is an imaginary straight line that runs through the north and the south poles. In the past, around 4.5 billion years ago, an object of the size of Mars that crashed into the Earth. Okay, it knocked our planet over and left it tilted at an angle. Ever since the impact, the Earth has been orbiting the Sun at a slant, and this slant is called, you know what? The axial tilt. Earth's slant is around 23.4 degrees and is decreasing, and it changes over the time through very slowly. The Earth always remains tilted towards the pole star as it moves around the Sun. Okay, the angle at which the Earth is tilted is known as the inclination of Earth axis. The axis is tilted at an angle of 23.5 degrees from the vertical, and this means that if a line is drawn parallel to the plane of the Earth orbit, the axis would make an angle of 66.5 degrees to this line. This topic, the Earth is rotating on its axis, creating day and night. At the same time, it's revolving all the way around the Sun. Okay, and the axis actually is a real or imaginary line on which something rotates on a straight line around which things are evenly arranged. An example of axis is an imaginary line running through the Earth on which the Earth rotates. Earth spins on its axis once every 24 hours. Earth axis goes from the North Pole through Earth center to the South Pole, and that is tilted. And it has a tilt of 23.5 degree. Students, the Earth is moving all the time. Okay, even now, as you're sitting in your chair or lying on your bed, the Earth is constantly moving. Okay, and that doesn't really make a lot of sense, does it? If you look down at the ground, it doesn't really look like it's moving, does it? So let's think about this logically. When I see moving, what do I mean? Does it bounce around like a ball over here? Does it roll around here and there? Well, let's find out. And that's the kind of movement I'm talking about when I say the Earth is moving. Means Earth is moving means it moves like this while also spinning around itself. And this kind of spinning movement, that is called rotation. And other movement, well, we will get that later, but you seen this kind of movement or this kind of rotation before for sure. For example, that is a steering wheel or a washing machine or a fan or even a top. Okay, imagine a point on this surface of the top. It starts there, goes around and behind, and it's back where it started. And it keeps doing it over and over and over, tracing over the same circle. Okay, So let's try it with another point. See, same to the point, just makes the circle and keeps tracing over it again and again. If I take another point that is going to be another circle, just a stop, do you see anything common among these three circles? Tell me and just guess. The centers of all these circles have the same center. Let's do something if we were to connect these centers. We have a line running from the bottom of the top all the way and to the top of the top. This line is called the axis. Okay, an axis is an imaginary line that any object rotates around. The axis is just a concept. It's not a real thing, We just assume it. It's there. Have you ever seen anyone spin a basketball on their fingertips? We can try sometime, but I know that I can't do this. I'm sure you are better at this moment, Please have fully cool. Right. To the axis here would be, so the axis would be right through the center of the ball. And that's pretty much, how it is for the earth. Only differences is at the axis of the earth is a little tilted. And the earth is tilted an angle of 23.5 degree. So the axis isn't straight. It's sort of slanting as it spins, and it confused about how much is tilted. Okay, let me explain it through a clock. If we imagine that minute hand is to be the time of reference at 9 p.m. Okay, the hour's hand makes an angle of 90 degrees. Understood? 90 degrees, right? Let's get half of this. So that's 45 degrees next to a half once more. That 22.5 degrees. And the earth is still tilted one more degree, that is 23.5 degree. It said that this angle that the earth rotates well. That's the reason for you waking up and going to sleep if it was in for the rotation of the earth. You wouldn't have day and night. So yes, it does affect you a lot. You don't believe me, right? Okay, come on. So what we have here, a table lamp and a globe. What do you notice? This circular segment of the globe is illuminated and the rest is in darkness. And this circle is called the illumination, okay, circle of illumination. So now if we imagine this globe to be our planet Earth and table lamp to be the suns, the part of the earth that is under the circle of illumination will experience day, and the other part which is in darkness will experience night. And see, isn't it? Circle of illumination. Again, see how the rotation controls your day. Doesn't matter where you are in the world. The rotation of the earth affects us all the same way. It's morning. When you enter the site, when you enter the circle of illumination, once you will enter the site that's in it, it's going to be daytime. And after that, it's a straight trip to the dark side, and your day gets darker and darker throughout until it is night time and the time for you to sleep. But when you are asleep, the earth is still rotating and the circle of illumination is on its way to you with another morning. That is how the rotation of the earth affects your day. Actually, it doesn't just affect your day. It is your day, a complete rotation from this point and all the way around and back to this exact point again. Take exactly how many hours? 24 hours. And that's why a day on earth is 24 hours long. and it just for one full rotation. Okay, thank you students.